And now we're talking about the RWI B21 Robot Base. It's in excellent shape. It's almost like new, but you know what to look for. This is a 4-wheel drive synchronous mode robot base. It's got about 4.5 inch diameter wheels. It's 12 inches high, about 20.5 inches in diameter with no extra plates. It weighs 80 pounds just like this, with no batteries, no side covers, no extra plates. You add 100 pounds of batteries, the upper base plates, and the base covers, and you're up to 212 pounds. And this doesn't have a computer or anything. It's got a couple motor amps, some DC to DC converters, and a few miscellaneous switches and things. It's a raw base. Now we're talking about the B21 Robot Base. The bottom. 1/4 inch plate, really good condition, no scratches or anything. It's a synchronous drive robot. 1, 2, 3, 4 wheel assemblies. Wheel assemblies go pretty much from here to here. It's got a 3-to-1 gear reduction. The rest of it's belt driven. Synchronous drive. The wheels rotate together, they steer together. There is the fixed base and a rotating top plate. When the wheels turn, the top plate turns with it. But this is sitting on the floor upside down. So watch the wheels as I rotate the body. Note, they are still pointing in the same direction. Synchronized motion, synchronized drive, synchro drive. 4 wheel assemblies, 3 drive motors, 1 orientation motor. This is the base of the B21 robot. This is the real world interface RWI B21 Robot Base. Right side up. It's got a top 1/4 inch thick rotating plate, followed by 2 more 1/4 inch plates. 4-wheel drive, 4.5 inch or so wheel diameter. It's got a wheel assembly, which is approximately 3-to-1 gear reduction. The rest of it's belt driven and synchronized. The overall drive ratio is 18-to-1. The top is also belt driven. Overall ratio is 110-to-1. It uses 1 drive motor for the orientation and 3 of these brushed DC motors for the motivation power. These motors, about the size of an air can. The wheel assembly is about 12 inches off the ground. 1.5 inch ground clearance. Top plate, 19 inches in diameter, but if you add for the actual lower part, it's closer to 20.5 inches. It's a synchronous drive robot. The top rotates in sync with the wheels. When it rolls, all the wheels are synchronized and roll together. So when the top steers, the wheels steer. Note when I rotate the top, the wheels follow. Synchronized motion. It has a central spire, if you want to call it that, with slip rings which go to the 24 pair 26 gauge ribbon cable, which conducts serial communication, a couple signals, and the power to power the upper stage. Each motor is brushed, and there's 2 motor controllers. One for the orientation steering motor and one for the drive motors. 3 motors plug into one motion controller. Each motion controller has a corresponding encoder on the orientation and one of the drive motors. Has bays for 4 batteries, and each motor uses about 75 watts. When you use this, you may have to align the wheels to make sure they're all pointed together. There is a little mechanism here that you can adjust each wheel to make sure it's in alignment. You know, if it jumps a cog on the belt or the belt isn't quite in alignment, you can adjust each wheel to get it pointed in the same direction. When you use this, you probably have to do an odometry correction as the wheels wear. The diameter will shrink. What was the odometry setting for last year may not be for this year. Same for the orientation, to make sure that the rotations are matched up for heading. This is covered with side panels. But for the basics, this is an 80-pound aluminum robot base. We're talking about the RWI Real World Interface B21 Robot Base. I'm going to talk a bit about power. It has 4 drive bays with a sort of hot swap connector. It's on a little plate with a little pull tab. The battery is a 12 volt 33 amp hour battery. It weighs about 25 pounds. 26 pounds. The battery has a ridge on the top with this mates onto. You hook up the wires, make the connection, and when you slide the battery in, it has a mating connector on the inside and it connects. This works if you have the exact battery that fits. Batteries change though. Fits on there snugly. To swap the battery, you slide it in till the connectors match. Basically it bottoms out, and you have 4 of these for power. 26 pounds, 12 volt, 33 amp hour. Runs on 48 volts. About 110 bucks a battery. You probably are familiar with these. 12 volt, 18 amp hour, UPS type batteries. A lot cheaper. You'd think, oh, just take 2 of these. Nope, they won't fit. They are about the same length and height, but not the width. You can't get 2 of those in there. There's also a metal rib that it won't go any farther over. You could run this on 4 of these 18 amp hour batteries. You won't get as much run time, but it would work. We suggest a 32 amp 12 volt lithium ion type battery. It's about the same physical size, top post. There's no central part for this to mount on though, so you have to invent something for that. That would give you more payload for the robot also. Maybe a longer battery life. But that's the 12 volt 32 amp hour lithium ion versus the 33 amp hour lead acid. 48 volts. It should give a nice run time. Furthermore, end of story. The B21 Robot Base is covered with 8 door-like panels that are removable. Each panel is made out of aluminum. It has 3 aluminum ribs, 4 IR sensors hooked in serial to a ribbon cable connector, 4 latch type panel sensors. This determines if the panel is fully connected. That's what these little ribbon extra cables are flopping around for. They connect to the panel. There are no bump type switches on here. There's nothing to say you hit something other than the 4 IR sensors. 3 point straight ahead, 1 points down. This weighs a little bit over a pound, and it can swing out and then kind of latch closed. The 8 IR lower base panels. This is the B21 base, 12 inches, about 1.5 inch ground clearance, the rotating upper level. This is the ground floor of the B21 robot. 1/4 inch plate, 24 pin, 26 gauge ribbon cable connector connects the bottom to the top. The belt layer and the slip ring layer. Down here we have the motors, the battery bays, the wheel assemblies, and some electronics. The next level up on this one is the LiDAR layer. That's another plate with a shroud. That looks like this. If you notice, it has a cutout for the LiDAR signal, the beam, pre-drilled for the SICK LiDAR unit. It's also got a machined edge for some other electronics like a Wi-Fi of this age. This has a cutout for the ribbon cable, and it connects and gets bolted down like that. LiDAR sits here. The the interface sits here, and the next layer sits on top. B21 LiDAR level. We're talking about the B21 base LiDAR layer. This has cutouts for the LiDAR beam, so it has a free view of what it can see. This also has a cutout for the ribbon cable, and there's a top plate that bolts on here. This is that top plate. It's got a hole for the LiDAR and a cutout, if you can get your hand in there, to hook up the monstrous 24-pin, 26-gauge ribbon cable, which carries the 48-volt power serial communication, a couple signals between the base and the upper robot. No computers down here, it's on the upper level. This plate has these 4 lift handles, but they also are lockdowns for the upper level. This plate sits on top of to form the top of the LiDAR layer. I'll put a screw in because this won't stay up by itself. And you would hook up, well, you'd reach in this little hole, but you'd hook up the ribbon cable, which just brings the signals up a layer. This is the top of the base of the robot. It has cutouts and pre-drilled holes for a typical SICK LiDAR unit, which has the spinning beam to send light laser pulses out to measure its distance. Serial communication. That sits about there. Into the upper level, but this is the base of the robot. The upper layer sits on here. There's a couple guide pins and the LiDAR unit. The base for sensors has just the LiDAR, the 4 per 8 door IR sensors with 8 pointing down and the rest pointing forward, and the open beam area for the SICK LiDAR. Top of the base unit. Approximately 121 pounds. This is the B21 lower base sitting on a carousel, so I can rotate it to go through each area and describe what's going on. We have the belt layer, which is synchro drive, so if you watch the wheels, they rotate. We have a drive motor, it's brushed DC, they're all brushed DC, hooked into belts. We have a battery bay, which has a connector in it, where you would put in one of the 12 volt 33 amp hour batteries, 4 total. Has some switches. This one says base, this one says enclosure. We also have a battery charge port, 48 volts. It looks like a standard connector, but it's keyed a little bit different. battery bay. Here you have a Vickers DC to DC converter, 12 volts to 5 amp, sorry, 48 volts to 5 volts. This is a panel connector serial for communicating with the door panels, 8 of them. We have a wheel assembly, 4.5 inch or so wheel, 3-to-1 gear reduction, overall 18-to-1 between the wheel and the motor. Another wheel drive motor, serial, no encoder, belts, another battery bay with the hot swap type connector. We have a motor controller with, of course, the panel door cables. This motor controller probably does this steering motor, which has an encoder, 110-to-1 overall ratio. If we rotate the top, you can see this moving. Some electronics behind it, most likely serial multiplexers where they combine multiple serial cable or signals into one address for the serial communications. Another battery bay, steering motor, gear reduction or step down, another wheel assembly, another serial port multiplexer, panel doors. This is a main drive motor. Remember, there's 3 all hooked together, but this one has the encoder. So this would be the primary master wheel drive motor. Another battery bay, but on this panel we have the base, I guess you call it controls. On off switch, couple push buttons, couple serial ports, and some LEDs. It's hooked up to a serial cable, which doesn't really come apart. And to take the panel off, you have to take this off. Should have put a connector on it. Another drive motor controller, most likely for the wheel power. Panel door covers. This little part right here is an adjustment. You can loosen this to rotate the wheel assembly in case you're off a cog or something on the belt and it's not pointing true. There's some adjustments. So, third drive motor, back to the switches and the charging port. B21 lower base. So now we're going to talk about the side covers for the B21 Robot Base. This is one of the side covers, panels, whatever you want to call it. This one's got the cutout for the controls. It's also got a yellow dot above it. 4 IR sensors, 1 pointing down with 1, 2, 3, 4 door sensors. There's pins that push against this to make contact. Goes through the serial cable. So we're going to put this panel on. This will be a little slow and messy. Here's the controls. This uses some 1/16 inch screws. 1/16 inch socket, Allen wrench. And there's the controls. It's got a little room on the cabling. You have to hook up a connector. And now you don't have a lot of room. The next step, I got the right one. There's a retaining screw to keep it from dropping. The panels are a little tricky to place because that cable's just not long enough. These are springies. You have to push against the spring to get this in place. I probably got the cable twisted. Basically the panel goes up. It's held in from a screw so it doesn't drop. To put the panel in, it's a bit of gymnastics, because you have to get it in the matching hole and press against the retaining screws. So then you take your 9/64 inch socket or Allen wrench while holding the door up so it doesn't fall off. Put the screw inside this pin, if you can get your fingers in there. On this particular door, it's the hardest one of all because of the extra cabling. Then you can let go of the door. Whew. The door is connected. We have the front, the base panel connector. We'll put that back on. We have the IR sensors communication cable. We'll put that in. And ta-da, this panel is installed. This little bit of up and down motion is how it latches to the bottom pins. So spin it around. One panel installed. The next panel installed about the same way. You have your connector, the panel with the pinholes. I took the screw out for this one. And I think it's going to be easier . Then we put in the screw, keep it from falling off. Get it aligned right. So now we have to hook up our cable. So then we can shut this door and shut that door. And we'll spin it around again. To open panel, to close the panel. And I will do the rest of these off camera because it's just a repetition of the same thing. The B21 base has its panels on, installed now. Some of the panels have a color code. This one has a red dot and a white dot. Battery and charger. It's also got the controls for turning on the main power. IR sensors. Has this little springy thing. This helps keep the panel closed. It pushes it up so it catches these pins to latch, and it compresses these little door sensors. So this panel, red and white dot, now closed. This panel has no dots, motor. This panel has a dot, battery compartment. This panel has a yellow dot, but it has the controls and of course serial port and stuff. This panel partially opens because it's colliding with the encoder, so you have to lift it up until you find a cutout in the side of the door that matches the encoder. So this has the controls, the IR sensors, the main orientation motor, wheel assembly. Close it. Yellow dot. White dot. Another battery compartment. No dot. Wheel assembly. White dot. Battery compartment. No dot. Wheel assembly. And now we're back to the closed panel with the red charger. So on this wheel assembly, has no encoder, no notch in here. So we will close the panel. Next panel, battery compartment. Closed panel. Went through the controls, closed panel. White dot, battery compartment. Closed panel. No dot, wheel assembly. Closed panel. White dot, battery compartment. Closed panel. No dot, wheel assembly. Closed panel. 8 panels. Back to the red dot, white dot, battery compartment, and charging cable with the switches. So this is the lower base with the panels installed. And back to red dot, battery. Base with the panels on. The next step on the B21 Robot Base is to put on the LiDAR layer. That is this panel, this layer with the beam cutouts for the LiDAR and the mounting holes for the SICK LiDAR unit. This is the upper plate with the connecting ribbon cable, the 24-26 gauge power and data cable. So this plate and using a 5/32 we can put the parts together. You can't get this top plate on if the LiDAR unit's already installed, so you have to put this on, then put the LiDAR on, and then install it onto the robot base. Then it gets more fun. Rather than tightening the screws, that's this layer, which I'm going to tighten off camera. The LiDAR layer has been bolted together. The next step would be to bolt in the LiDAR unit. It basically sits there and is held in with 3 screws. I think I'll do that off camera because it looks like it'll be a little bit of a balancing act. Or maybe not. We'll try it upside down. We'll take the LiDAR unit, place it upside down, place the LiDAR layer on top, we have the LiDAR installed onto the LiDAR layer. Next, we'll take off the dust protector. We'll place the LiDAR unit on top of the base, and we'll connect the ribbon cable. LiDAR layer needs to be bolted down. That's just a matter of putting in a few screws. And the base is almost intact. Remember, this is synchro drive. Motion. You can see the beam area. Spin it this way. No. The beam area for the LiDAR. It's got this opening. I'm getting off center of my carousel. And this is the top layer, mounts on top of this layer. With that, I'm going to stop this video and take it off the carousel. The B21 base LiDAR layer, I determined that it's easier to connect the ribbon cable. I don't know if you can see it down here where my fingers are. If you place it on the little handles, so you get your hand in here, because the LiDAR in it actually covers the cable, so you can't get the cable on if this is in. So you have a little bit of slack, just set it on the handles carefully so it doesn't fall on your fingers, and then you should be able to place it in place. So then we have to drop the LiDAR layer back down carefully. LiDAR layer has a series of holes such that if you take one of the screws with a 3/16 inch Allen, do the easiest one. So we have one screw in. We're going to continue putting some more in. These are somewhat easy. One we've already done. So far, so easy. I might have to do the rest of these off camera. Maybe I can get one of these in the back. Maybe. I have to use a piece of tape. Now right-handed operation. And that secures the base to the LiDAR layer of the base. It's like my carousel is getting off balance. So we'll go back to the red and white dots, straighten it up. Base is in one piece. I'll get rid of the carousel so we can see what it looks like when it's sitting on the ground. So now we have the B21 Robot Base on the ground. Panels installed, LiDAR layer installed, the wireless bridge installed. That just kind of sets in there. About an inch of ground clearance, foot up to this layer, 16 inches to the top of the LiDAR layer, and with the LiDAR on, it's about 19¼ inches tall. With the panels on, it's about 21 inches in diameter. This is the base of the B21 robot. Upper layer fits on top, uses these guide pins and little hooks to attach to this layer. With batteries, this weighs about 221 pounds. So this is about 121 pounds without batteries. The B21 Base.